Mars is one of the closest planets to Earth, orbiting the Sun in the habitable zone. Mars wasn't always a cold and barren world ruled by raging dust storms covering the entire planet. Instead, it was warm, had lakes of liquid water, and was habitable for a short period of time. Most people know that, but nobody knows exactly what happened to Mars that it lost all the water during the past billion years. How did Mars's habitable atmosphere vanish? And most importantly, scientists have observed strange quakes on Mars. What triggered these quakes? Is Mars's core still active with volcanoes? Or did something else cause this unique occurrence? Mars once had rivers. The traces of ancient rivers, streams, and lakes are visible today all over the planet, but they all dried up about 3 billion years ago, and no one knows why. Previously, many scientists had assumed that losing carbon dioxide from the atmosphere, which helped to keep Mars warm, caused the trouble, but the new findings suggest that the change was caused by the loss of other essential ingredients that maintain the planet warm enough for running water. In 1972, scientists were astonished to see pictures from NASA's Mariner 9 mission as it circled Mars from orbit. The photos revealed a landscape full of riverbeds, evidence that the planet once had liquid water, even though it's dry as a bone today. Since Mars doesn't have plate tectonics to shift and bury the rock over time, ancient river tracks still lie on the surface. Now the question is, how did Mars lose its water? A planet's magnetic field is a fundamental ingredient that decides the course of events there. It is an entity that can cause the difference between life and death. Earth's internal magnetism creates a region around the planet known as the magnetosphere. Life on Earth initially developed and continues to be sustained under the protection of this magnetic environment. The magnetosphere shields our home planet from harmful solar and particle radiation, as well as erosion of the atmosphere by the solar wind, the constant flow of charged particles streaming off the sun. The magnetosphere swaddles the Earth like a protective blanket. The sun's solar wind strikes the magnetosphere and is forced to flow around the planet instead of reaching the atmosphere or the surface. The magnetosphere is not a sphere. It is moved into an asymmetrical shape by the solar wind and prevents the solar wind from stripping away Earth's atmosphere. Without it, Earth would be dry, dead and barren, just like Mars. 4 billion years ago, Mars had a magnetosphere that shielded it from harmful solar winds, but eventually it lost its magnetism. Strong solar winds stripped away the atmosphere that Mars once had. But what mysterious thing happens in Mars's core that causes the planet to lose its gravitational field? To understand this, let's look at our home planet first. Here on Earth, the dynamo effect produces the magnetic field. We know that the Earth has a solid inner core and an outer liquid core. As heat flows from the inner to the outer core, it generates convective currents in the outer liquid core. These currents further flow in patterns driven by the planet's rotation. And eventually, this flow of current generates a magnetic field and the Earth develops a magnetosphere. Scientists believe that a similar phenomenon should have created a magnetic field on Mars in the past. And to confirm their hypothesis, they used data from NASA's InSight lander on Mars. The robotic lander InSight is designed to study the deep interior of the red planet. InSight was launched on May 5, 2018, and it is still researching the geological evolution of Mars. InSight has obtained some critical information regarding the inner structure of Mars. After carefully examining InSight data, it was proposed that the core of Mars is much larger and less dense than previously thought. NASA's lander InSight struggled to meet all of its scientific objectives, but it has gathered some critical evidence regarding Mars's interior structure. If InSight's results are correct and the implied hydrogen exists, then there is a basis for experiments that could reveal more about Mars's lost magnetic shield. Despite its importance, the iron, sulfur, and hydrogen system has been investigated slightly under high pressure. But if data from InSight is correct, the hydrogen in the iron, sulfur, and the hydrogen core might have played a role in the collapse of Mars's magnetic field. The researchers prepared a material sample matching what they thought Mars's core was once composed of. It contained iron, sulfur, and hydrogen. They placed the sample in a device called a diamond anvil. A diamond anvil compresses samples between two small diamond plates. Diamonds can withstand extreme pressures inside the anvil because they're forged in intense pressure deep inside the Earth. The anvil can subject microscopic samples to pressures of hundreds of gigapascals. A laser heated the sample so that the conditions simulated Mars's core. As the team subjected the sample to higher temperatures and pressures, they observed it with X-ray and electron beams to track changes in the material. The sample containing iron, sulfur, and hydrogen melted, and they also changed their composition. The experiment's results center on the idea of miscibility. Materials are miscible when they're added together and create a homogeneous mixture. When materials are added together and don't make a homogeneous mixture, they're immiscible. The immiscibility of iron, sulfur, and hydrogen at high temperatures and pressures played a significant role in Martian planetary history. One of the iron liquids was rich in sulfur, the other rich in hydrogen, which is key to explaining the birth and eventual death of the magnetic field around Mars. Among these separated liquids, the denser one stayed at the deepest part, while the lighter one migrated upward and mixed with the bulk liquid core. The movement of these liquids generated some convection currents that are still going on inside Earth, which is a possible reason why Mars also had a magnetic field 4 billion years ago. But something else happened in the region where the two liquids separated. As the liquids separated, there was no motion to fuel the convection. At the same time, gravitationally stable and compositional stratification might have developed in the region where liquid separation took place. Eventually, Mars's entire core became stratified. Convection ceased. In other words, once the two liquids separated, there was no longer any convection, and finally, no magnetism, and Mars was doomed since there was nothing left to hold its atmosphere. Scientists already knew when convection ceased and Mars lost its magnetic shield. That happened about 4 billion years ago. The next question is, why is Mars rumbling? Another data segment reveals that InSight has found Mars rumbling with quakes. Since arriving on Mars about a year and a half ago, InSight has detected about 322 Mars quakes. They are the first quakes ever detected on Mars and the first on any other planet than the Earth and the Moon. Scientists aim to use them to probe the Martian interior, including deciphering the planet's guts into crust, mantle, and core layers. Most of the Mars quakes are tiny, much smaller than anything that would be felt on Earth, but a couple have been big enough, up to nearly magnitude 4, for scientists to be able to trace them back to their source. Recently, a team of researchers have detected 47 new seismic events coming from the Cerberus Fossae region. However, since the quakes didn't follow any particular pattern in the timings of their occurrence, it was clear that they were not a result of the planet's interaction with its moons. Moreover, the quakes repeatedly occurred at all times of the Martian day. This suggested that the movement of molten rocks in the Martian mantle triggered the Mars quakes in this area. Research also found this region to have been volcanically active in the last 10 million years. And this activity is attributed to the repetitive movement of magma in Mars's mantle. NASA's InSight has detected the largest quake ever observed on another planet, an estimated magnitude 5 trembler that occurred on May 4, 2022, the 1,222nd Martian day of the mission. This adds to the catalog of more than 1,313 quakes that InSight has detected since landing on Mars in November 2018. The type of tremors occurring on a celestial body can reveal much about its interior makeup and activity. However, not all of Mars's rumbling is caused by interior activity. For example, one of the 1,313 quakes detected by InSight was caused by a meteor strike. A meteor collided with Mars on the eve of Christmas in 2021, causing the planet to shake so violently that InSight actually captured the rumblings. The cause of this Mars quake was unknown for a long time. However, the Mars Reconnaissance Orbiter just spotted a new impact crater on the planet. The crater was discovered to be around 500 feet broad and more than 10 times larger than the normal new craters seen on Mars. Furthermore, boulder-sized pieces of water ice surrounded the crater, presumably thrown up from beneath the surface during the explosion. Detecting Mars quakes near Mars's Cerberus Fossae region might be one of the most significant occurrences during InSight's mission. So far, the lander has contributed much to our understanding of Mars's geology. Unfortunately, it may no longer be capable of doing so. Martian dust has accumulated on the solar panels of the InSight lander in the past 4 years. Another dust storm just slammed it, which may have been the last nail in the lander's coffin. As a result, InSight will most certainly run out of energy soon, bringing its Mars research adventure to a conclusion. What do you think about the possibility of life having once existed on Mars? Tell me in the comments. Thanks for watching.